Hi, and welcome to our first lesson of mathematics for the classroom. Today, we will be discussing limits using an intuitive approach. This approach is handy if you are new to calculus or a novice math student. The other approach is sometimes referred to as a rigorous approach. The rigorous approach is applicable if you are majoring in mathematics or have a solid background in mathematics. It involves using the Greek symbols epsilon and delta. For the intuitive approach, there is some prior knowledge required to fully understand the concept of a limit. Firstly, you need to fully understand what is meant by a functional value. Secondly, you need to understand the concept of what is meant by x tends to a number or x approaches a number. And thirdly, limit notation. Firstly, let's look at what is meant by the concept of a functional value. In this example, we have f of x equals x squared minus x cubed. Now, if we take a value, you can take any value. I just chose x equals -1. If you draw a vertical line through -1 until the vertical line touches the graph like so, at this point, we draw a horizontal line towards the y-axis. This value is known as the functional value of x equals -1. In our case, we can calculate the functional value. It would be -1 squared minus -1 cubed equals 1 minus -1, which is equal to 2. Thus, the functional value of x equals -1 is the number 2. Let's look at another example. Let's take x equals 1.5. Firstly, we draw a vertical line through x equals 1.5 until the vertical line touches the graph. From this point, we draw a horizontal line towards the y-axis. This value here would be the functional value of x equals 1.5. It's not clear on the graph what the numeric value is of the functional value, but we can calculate it algebraically as follows. F 1.5 equals 1.5 squared minus 1.5 cubed equals 2.25 minus 3.375, which equals -1.125. So this value here is y equals 1.125. Next, we will be looking at the concept of tends to or approaches in conjunction with a limit notation. For this illustration, I will use the graph f of x equals x squared plus 1. Now, it is important to realize what the concept of a limit seeks to investigate. When we calculate the limit of a function at a point, say x, we seek to investigate what happens to function values of numbers close to or in the vicinity of x. For example, let's take x equals 1 in this example. If we wish to investigate the limit of the function f of x equals x squared plus 1 at x equals 1, we need to inquire what happens to the function values of x values both on the left-hand side and on the right-hand side of the number x equals 1. Let's look at the function values from x equals 0.5 to 1 on the left-hand side, and function values from x equals 1.5 to 1 on the right-hand side. Let's take this number here and calculate its function value. Its number is a number just below 1.5. Let's move closer to 1. This function value is just above 1.5. Let's get even closer to 1. This function value gets closer to 2. Lastly, let's see how close we can get to 1. It's imperative to understand that the concept of a limit investigates what happens to the function value here. It seems as if the functional value gets closer to 2 when the x value approaches 1 from the left-hand side. In mathematics, we write it as follows. The limit of f of x as x approaches 1 from the left-hand side is equal to 2. The superscript, the minus sign, means x approaches a number from the left-hand side. Let's see what happens when we approach 1 from the right-hand side. Let's take this number and calculate its function value. This function value is just above 2.5. Let's take a number closer to 1. Function value is just below 2.5. Let's see how close we can get to 1 without touching 1. This function value is even closer to 2. It seems as if the functional values get closer to 2 when the x values approach 1 from the right-hand side. We write this as follows. The limit of f of x as x approaches 1 from the right-hand side equals 2. The superscript, the plus sign, means x approaches a number from the right-hand side. For a limit to exist at a number, both the left-hand side and the right-hand side limits have to be the same. In our case, we can write the limit of f of x as x approaches 1 equals 2. Please note, if the left-hand side and the right-hand side limits aren't the same, we say that the limit does not exist at that point. See you soon.